Alright, amazing hackers. Hope you're all doing well today. Welcome back. This time not to the channel, but to one of our courses. We have different types of cross-site scripting out in the world, of course. It's really funny because, this moment you're just browsing casually throughout some website that you found with different types of nice little exploits active, such as our stored cross-site scripting labs, for example. If we go and visit there and if we simply log in, we can see some awesome things going on right there. You might think this is self-XSS, but I promise you that it's not. Now, if you log in, you should be able to just log in with this username and password, but that's not the cool part about this, of course. This is just a little bit of a demonstration of all of the cool shit we're about to do. Yes, indeed, my friends, this is also going to be for you. You're going to be doing the same thing as me, which is popping up in a little prompt, but not just that, of course. We are going to take over an entire account. We are going to do some awesome stuff. We're going to chain our cross-site scripting, and we're going to learn about the different types of cross-site scripting. So, are you ready? Because I know I am. I'll see you in the course, my friends. Hey, what's up, you amazing hackers? Hope you're all doing well today. My name's the thexssrat or Wesley Tays. Now, why did I name myself the thexssrat? Because I think cross-site scripting is awesome. Cross-site scripting comes in many flavors, not just JavaScript, but we'll get more into that later. What are my credentials? I've been in cybersecurity for about 5 years. I've been in general IT for about 13 now. I've been a programmer, I've been a network engineer, I've been a QA engineer, I am a pen tester. Now I have my own pen testing company, and I just love XSS to death, don't you? Well, you will at the end of this course, I'm sure of it. Let's fly deep. Let's dive deep. Let's dive deep into it. So on the agenda first, let's see what we're going to cover, because we have quite a lot to cover, starting with what cross-site scripting actually is, the different contexts of XSS, the different types of XSS. As you can see, there are multiple types. We'll also check how to test for XSS, because that's a question I often get. We'll talk a little bit about how to get around filters, but we have a full chapter around that, so we won't fully go into that now, and raising our impact. Let's start with what cross-site scripting really is, because there's quite a few misconceptions about it, I would say. First of all, XSS allows attackers to inject client-side scripts. This happens because developers do not sanitize user input. So you can imagine you're a developer, you're making something where you're displaying data controlled by a user, and the user can insert malicious scripts. Don't think it's only possible in JavaScript. Scripting is any type of language, such as VB script, ActiveX, Flash, and even CSS. Most commonly, though, you will find that JavaScript is vulnerable to XSS, because most commonly JavaScript is being used. It's simply that simple. It's not because there's some magical properties to it. There are different contexts in which XSS can occur, so let's talk about that basic context first, which is going to be your HTML context, your HTML tag context. We also have the HTML tag attribute or JavaScript. Those are the three mains we are going to focus on, and then you also have XSS and JavaScript template literals in context of the AngularJS sandbox, in context of CSS, in context of the headers. So there's many different contexts in which our attack vector can occur. What does that mean? There's also different types of XSS, of course. I think it's important to maybe talk about those first, then we'll get into the meaning of those contexts. We all know the reflected versus stored, but there's also DOM-based versus source-based. Source-based being the reflected and the stored, but there's also others like blind, mutation. There's even XSS through CSTI. It's just that the main ones you'll hear about are reflected, stored, and DOM. I want to go a little bit deeper though. Let's talk about reflected first. So let's imagine again that you are that developer and you have user input being reflected on your website. Let's say, for example, a parameter, you ask for the name, question mark name equals, and then if that's filled in, you say hello, and then the value of that name. If you don't filter it well, and that value is not stored on the server, but simply reflected directly, this is an attack that is called interaction full attack, because basically I'm going to have to get my victim to perform an action such as click a link. So they cannot simply stumble across this because this is never stored on the server. This can happen into an attribute of an HTML tag. If you don't know what that is, imagine you have your for example, an A tag, a link tag. You start with your less than sign, then you type your A space href equals. That's a tag attribute. You can also have it into the JavaScript context. User input does not get stored into any databases, nowhere on the server basically. It might get stored, but it doesn't get retrieved from that to execute your cross-site scripting. That is not what this one is about. User input is again not properly sanitized, where the user input can contain JavaScript code or any other scripting language that is basically active at that moment. This can occur with post calls as well, which is where we're going to add CSRef into the mix, but not yet. I'll show you that in my labs as well. That's an important one. The types of XSS for stored is different, because here the input does get stored into a database, and the database values get reflected into the HTML page, into again one of those HTML tag attributes, or into JavaScript context. Others as well are possible. With stored, user input is not sanitized properly, but sanitization is one thing. You can do sanitization and inspection of data. You need to do this at certain points when you insert the data into your database and when you read the data back from your database, or data source is a better term here. Also at input, so even before you're going to write to the database, sanitization, filtering is also pretty good idea there. User input can contain malicious JavaScript code at any moment, or any other scripting language, and should never be trusted for the life of you. When it comes to DOM cross-site scripting, this is different than stored or reflected. The DOM never gets processed by the server at all. So like reflected doesn't get stored on the server, but still processed by the server. With DOM, we enter what's known as the document object model. When you have a website, we all know the source code, you know, all of those tags that you can see when you click view source or inspect. Well, those are your source code, but if you hit the back button, you also need to know, your website needs to know where to bring you, your browser needs to know where to bring you. That is part of your DOM, your document object model. Anything that is not your source code but still related to your website. And we have what's known as DOM sinks and DOM sources there. An example here is, for example, results.innerHTML. This is a DOM sink, and then it will be reflected into a DOM source. Again, different because this value never gets processed by the server. A famous example is the pound sign after a link. Imagine if you have a link with a pound sign behind it, and then you have some data there. You can use that, for example, to go to a certain location on the page, but that data can also go directly into a DOM sink and get reflected into a DOM source. Now, I'm not going to go too deep into it into this chapter. We have a separate chapter for this, but just know that it exists. A DOM sink can, for example, be eval, inner HTML, etc. Most common sources for DOM XSS arise from windows.location. Remember that pound sign, usually in a query string or in a fragment portion of a URL. When we talk about DOM versus source, once again, we've talked about that difference. We know that things like history, things like URL, This needs to be tested though. It's important to mention DOM cross-site scripting needs to be tested in your development console. There's no other way. Blind XSS relies heavily on out-of-band servers. Now, if you don't know what that is, say that you're testing an application, you might want to set up your own server for testing if requests come in. If the target is sending out requests through, for example, blind XSS, because if data is being collected, you need to send it somewhere as well. That is where out-of-band servers come in. It's basically just a server that you can send your data towards. Later we get a call informing that the payload is triggered. This really what happens here basically, let's get back to the basics first. Blind XSS is when I insert an attack vector and I cannot see the execution of it myself. For example, I enter a ticket. You as a customer will have a front end where you can enter your tickets. Then it'll get picked up by service desk, which has a different front end than you. Your front end might not be vulnerable, but theirs might be. And you cannot always see their endpoints, so you might need to rely on blind XSS. XSS Hunter was until recently doing that publicly. You could make your own instance of it, but you could also just use the web version of it. It has shut down that web portion of it, but you can still use your own web server for it. Great for blind XSS testing, because later on you insert your attack vector and then later on you get informed, oh, you had a trigger. This can be stored or reflected. Reflected in case of knowing a page and parameter exists, but you can't access it. For example, I might know that a specific page exists, which only help desk can enter, and I know that parameter, which I can attack, which I can try to put my attack vector into, and I can send that to that help desk guy. I can send that link, and if he clicks it, then that is reflected. Cross-site scripting is the value is never stored on the server. For example, a ticket number. Ticket numbers, if you request ticket details, you enter a ticket number. That ticket number often gets processed into the database in a sense of you're going to request data, but you're not going to write data. So it's not stored specifically, and you can enter maybe an attack vector into that ticket number. Even though it says number, it might say when you don't have a number, oh, I cannot find number, and then your attack vector, and bam, you might have blind reflected cross-site scripting. Mutation XSS is a relatively new technique. This bypasses the DOM completely, and this basically means that we enter a broken attack vector with some extra things in it, but because of recent browser behaviors, they always try to fix that. They try to mutate your string. This might form a full XSS. This is a mutation as the browser mutates your payload, which might allow it to run. Just know that those exist. I won't go too deep into those into these courses. When it comes to XSS, we also have client-side template injection. Client-side template injection happens because we have front-end templating engines such as AngularJS and Vue.js, and if used improperly, again, we can have user-supplied values being processed by that templating engine, which might lead to client-side template injection. Just know that these client-side templating engines, they run in what's known as a sandbox, and trying to escape that sandbox is a true witch hunt and of itself. When we talk about those contexts, we need to go deeper into them, starting with the HTML tag attribute. In here we can see a basic head tag followed by a title tag, and that's how you close them if you didn't know, by the way, /title. And then we close the head tag, followed by a body where we will in PHP echo the get variable name to say hi there Wesley, for example. But we can enter any, and I repeat, any HTML tag that we want here, even a script tag. So we already have HTML injection, but if we enter a script tag in here or some kind of HTML tag with a tag attribute that will execute a JavaScript event, an event handler, well, then we have cross-site scripting. I will give you a good example. Script prompt slash script. Do not use alert, because as you will see in my labs, alert is one of the most filtered words out there. I would also advise against using the script tag, because it's very clearly often filtered as well. We can insert our own HTML text in here if the developer did not sanitize things properly. Make that execute a JavaScript, which executes arbitrary code, and followed by a cross-site scripting attack. An example you can see on screen right here. We have a image tag, just an image, a source tag equals X, and an on error, this is the event handler, and the JavaScript event being triggered, and here being confirm. Note that I do not use alert. Just so you know, in the tag attribute, in the on error, we can use capitals, we can use lower letters, it doesn't matter. The event itself is JavaScript, which is case sensitive. Let's talk about this HTML tag attributes for a moment, because here we can see again an example on screen with a script var name equals prompt, please enter your name, Harry Potter as a default, and then we see input onload this dot value equals name. We can already see how this can go wrong, because we can break out of this attribute right here, this onload, by simply entering a double quote ourselves, as we can see. Then we just close the tag and we can enter again any HTML tags that we want, including the script tag. Please note that we are again using confirm and not alert, as so often is used. One context that is also very important, of course, is your cross-site scripting context into JavaScript, which is where a user-defined variable or user-controlled variable, I should say, user-controlled input gets landed somewhere into a JavaScript file or JavaScript script in and of itself. It can also be inline, of course. Now let's look at an example of that. Here we have an example of a script where we have a variable search terms that gets populated, and you can already see what if we were to control it, FDS there, if we were to be able to control that, we might be able to insert a single quote in there, and then we can break out of the existing script tag. We can do that, or we can insert our own alert right after that, though remember, alert isn't that great. I prefer if you use confirm, prompt, whatever, as long as it does not alert. This is just for example cases, of course. We are going to use that single quote to break out of that JavaScript function. In our example, we are using a slash script tag to end the current script, and we are inserting our own script tag behind there. How do you test for this now? I have one attack vector that is the lazy passive method, and I have more of an active method. But let's focus on that passive method first. So with that JavaScript context, you basically have a single quote, a double quote, or a backtick that can be used to break out of JavaScript functions. For HTML, you can insert a simple broken HTML tag, and for the HTML tag attribute, we couple those single, double, and backticks. We couple them with a, in this case, greater than sign. All are pretty simple. We want to try to break out of these different contexts. So first, you need to determine what context did my input land into, where are we, and then we can try to break out of that context. If you combine that into a passive method, as soon as you register, you're going to enter the attack vector into every single input field that you see, being in this case a combination of this. So what you could do, for example, is a single quote, double quote, backtick, greater than sign, and then your broken image. If you want to even add CSTI and SSTI into that, you add a $sign, curly bracket 7 times 7. But we'll be seeing much more practical example of this as the course goes on. As we go further down the line, for example, let's say that you've entered this as your name. and then later on you're going to generate an invoice. That invoice contains your name, then you're automatically going to be testing for cross-site scripting in many different contexts here. This is what's known as an XSS polyglot. So if you ever hear that saying, that is what that means. The low effort of this makes it great because you can do this while testing for other things. It's easier to test hidden features by just clicking around, but you also have some other negatives, being that it is not very effective. Of course, testing with polyglot though is not very effective. Now, how are we going to test for reflected cross-site scripting? Here we want to make sure that this is a step-by-step guide. We want to test every single entry point, every single parameter. We want to submit a random value and we want to determine if we have that value reflected anywhere in all the contexts that we saw above. We want to test a payload based on that context that we're in, and if we don't get that, we want to test potentially alternative payloads or filter bypasses. What those bypasses are exactly, we'll get to that later. For stored XSS, a very similar thing. You're going to test every location, every input parameter that stores user input, and you will investigate the context in which it is rendered onto the page again, craft an exploit based on that context, and craft alternative exploits if your first one does not work. For DOM cross-site scripting, DOM, we are going to first of all look for HTML syncs. Now, we'll get more into all of the HTML syncs that are possible, but JavaScript has a few, jQuery has a few. You just need to know that automated tools are much more effective at finding this than you probably are going to be. Why is that? Because they can cover a much larger attack surface, and just finding a DOM sync doesn't mean DOM XSS, of course, but a DOM sync is already a pretty good indication that you might need to look further. Then you're going to place a random value into your sync, and you're going to inspect the HTML code with the developer tools only for sources. It's really important because if you right-click view source, this doesn't take the DOM into account. You have to inspect using the developer tools if you want to test for this. You're going to look for your random value. And if your string appears in the DOM, you need to identify the context in which it appears, craft the exploit based on that context, i.e. if a string enters into a double quote, we're going to break out of it by using double quotes. And if the data gets URL encoded before being processed, an XSS attack is unlikely to work. That's something you need to know. Getting around filters, we have different options. First of all, we need to talk a little bit about what filters are. There are many different types of filters out there. A first type that we will look at is blacklist based, in which we're going to, if we have that, blacklist based basically means that if this contains, so if your item contains this evil string, then block it. For this, we're going to try to fuzz all of the possible HTML tags and JavaScript handlers, try URL encoding or XSS attack factors, double or triple encoding it even, and try putting blacklisted words into other blacklisted words, as filtering might only happen once, leaving the original blacklisted word intact. We'll get to more examples of that in our practical labs as well. Whitelist-based filters will be very hard to get around. Only certain words or regular expressions or patterns are allowed. The rest is blocked. And then we also have pattern-based, which is going to try to look for things that look like XSS attacks. And this all depends on the configuration of how we can get around those. There's going to be separate chapters for that. They are already ready, so we will get to recording on that soon. And as for raising our impact, a lot of people have asked me, now what exactly can I do with this cross-site scripting beauty that you're showing me? We can, for example, steal cookies. This has gotten very hard recently because everybody knows about XSS, which is why a lot of people have enabled the HTTP only flag. We can execute a keylogger, we can execute JavaScript on the function, we can steal JavaScript function on the page, I should say. We can steal data from the page, we can steal CSRF tokens, for example, even leading into a full account takeover potentially. I hope this was useful, but let's get into some more practical tips and also the chapters separately, so maybe you can make more of an overview of what we're saying here. Now let's talk about testing for stored cross-site scripting specifically. Stored cross-site scripting, as we've seen before, but we'll repeat it quickly again, is just a form of cross-site scripting that is stored somewhere on the server. It can be in a database and then later retrieved and shown to the victim. Pretty easy, so that's the basics of it, but we all know that the basics won't cut it. We'll have to go a little bit deeper. We know that it's stored within the application, it's persistent, and this is often an attack vector which is seen as more potent than reflected cross-site scripting, not for the potential impact that it can bring, but rather for the potential of the victim just stumbling upon this attack vector while browsing and using the application. This affects any user who's going to visit that page. So stored input is not filtered correctly. We've already talked about this before as well. We need to filter and sanitize at input and when we show it again at output. This is often seen as one of the most dangerous forms of XSS as it doesn't require user interaction. We can also talk about second order XSS, but we won't for now. We'll get back on that later. As an attack scenario, just an example, an attacker can store malicious code into a vulnerable page. The user authenticates within the application and then visits the vulnerable page where the malicious code gets executed. This can be things like stealing your CSS token, stealing your session cookies, executing any cross-site scripting attacks basically. So that also means things like keyloggers and stuff like that. Now, here, how are we going to look for this? First of all, we have the design step in which we're going to create and test an offending URI. So a URL with a specific parameter and a path, and we're going to test that and we'll see. So that's your design step. Then after we have that implemented, we'll wait and see if it triggers. If we're able to trigger it, we'll craft a much more malicious vector, of course. Then we wait until the attack vector gets executed when the victim eventually stumbles across this page. There are some challenges though, because sometimes things might be filtered out, but we also have things like HTML encoding, URL encoding. It's not always simple to filter for stored XSS. This is more dangerous in areas where users can have higher privileges as well, because of course that is a good place where an attacker might, for example, steal a password, but they can execute any JavaScript that the application holds, any. So that also means if somebody like an admin comes by and there's a JavaScript function to make another user admin, and we have that information, we might be able to trigger it through cross-site scripting. As for the test objectives with this, we want to identify the stored input and where it's reflected in the client side. This can often lead to blind cross-site scripting as well, where we put an input in and with another application it is viewing that we do not have access to in an area that we don't have access to. We're going to assess the input they accept and see if we can't pass around any filters. Like for example, if your script tag is blocked, you'll try an image tag. If your greater than sign is blocked, you'll try %GT semicolon. There are ways around filters, but we'll get more into that in the filter evasion techniques. As for black box, we first want to detect the input vectors, where tester must define all user, controller, variables, and parameters. So anything that a user can control, any parameter needs to be identified. That is often easier said than done. Think about users or the profile page in the shopping cart, for example, but also applications that allow you to upload a file, like a file name, for example. Application settings and preferences, forms, message boards, blogs, logs, comment. There are so many places in which we can try to insert our attack vector. Then we're going to analyze the input vector, where we're going to try specially crafted input vectors for every single parameter. depending on the context that we are in. Of course, remember those contexts. So we can try, for example, a double quote greater than sign script alert slash script for breaking out HTML tag attributes, or we can try other tag vectors. In the HTML comment, I see that we are missing one greater than sign, but that needs to be there, of course. Now, analyzing the HTML code, we're going to try to find out where our values are reflected. We are going to try to, for example, look in all of the different contexts, see if our value is reflected there, and all data must be tested by inserting in user areas and then viewing in admin areas too. What do we mean by that? That is the blind XSS thing. If you have access to the admin backend and you have a username, for example, and the admins have access to a list of usernames, that needs to be tested for XSS as well, of course. Now we have beef, that also is something that we can talk about. I'm not gonna go too deep into it. I'll show you a different way to test for blind XSS with an out-of-band server of our own. When it comes to filter bypassing, we have a separate chapter for that in the course, but there's also a lot of variations online, of course, with XSS filter evasion cheat sheets. If we have an idea of how the application is built up, but we don't fully know it, in here we have like partial knowledge, not full knowledge, then we can craft the payload that is better suited for example, if we know exactly what filtering is being applied here, we can try to craft the payload that bypasses that filter. We are going to use the front-end application. We're going to enter the input with special and invalid characters. We're going to analyze what has been filtered out or why the application might be responding with a 500, for example. And we're going to try to see if we can get any special attack vector crafted for that context again. So gray box testing, black box testing is very, very similar. The only thing is that in gray box testing you'll have some information, making it a bit easier. But some don't know, sometimes I think black box testing is also easier, because in black box testing you don't have this preconceived notion of what will and will not work. It's just a thing. If you have some information, you have preconceived notions. We have some tools we can use here. I'm not gonna go through them in this chapter. These are just some useful tools, not super useful. There are some XSS scanners as well. I don't like most of them. It's just that XSS is a very, how do you put this? It's a very situational attack vector that you will always have to judge what you're doing. XSS scanners might help to a degree, but they'll certainly not find everything. We also have Burp, Zap, of course, XSS Assistant, Grease Monkey, Beef. We've talked about that a little bit before, but I would just advise you to go through these tools at your own pace. The most important thing that you'll need is character encoders for this type of stuff, and cheat sheets. Those are always useful as well, of course. Now, what I'm about to tell you might seem weird, but sometimes CSS, Cascade Style Sheets, is vulnerable to XSS. Now, what is it specifically? We all know that you can apply CSS to a website to make it look prettier, to give them styling, etc. So this is something that might sometimes execute scripting as well. This is important to know that this is just informative. This will only work in outdated browsers. So this is a very far thing in the past. I just thought it was cool and I want to mention it. We don't have labs on it either, but some CSS implementations allow for JavaScript by using the expressions directive. This will evaluate arbitrary JavaScript, and we can use that value in XSS parameters or XSS tags by using the URL JavaScript and then a colon and then the JavaScript that you want to execute directive. We can also sometimes execute JavaScript or with browser specific features such as the -moz binding in Firefox. Here we, for example, have an IE behavior Internet Explorer, where we can see a public component tag name XSS with the public attach event on document ready on event main. So basically when the document loads, we will execute whatever is in here, and this contains the script which is going to execute an alert. This is the CSS that calls upon the HTC with a body behavior, URL being the script.htc, and a selector having to match different HTML elements. This might all sound a bit like Chinese, but that's okay. You don't have to worry too much about this. Again, I thought it was just cool. We have some Firefox XBL behavior as well, in which we have the same thing in XML version 1.0 with different bindings, with a binding for the ID my code, with an implementation of a constructor that's going to pop an alert. So as you can see, there are different ways of popping alerts through JavaScript, through CSS I should say. It's not something that I think you should know exactly the details about. I just thought it was cool to mention. On to DOM cross-site scripting, because when it comes to DOM cross-site scripting, we have quite a beast to tackle. There are a few things that we need to pick up here. DOM cross-site scripting is pretty easy to pick up if you know what to look for, but we'll get more into that later. First of all, what is the DOM? You have the document object model, and you have the source code. The source code is, just like the name says, the source code of a website. Basically, it dictates how your website behaves on a certain level. You also have the document object model, like if you press the back button, for example, or if you need to interact with the URL, the document object model is the place to be. That is where everything is stored around your website. That is not your source code. If you want to test anything with DOM cross-site scripting, you need to use the developer console. Let me repeat that. You need to use the developer console. You cannot right-click inspect source. It doesn't work that way anymore, because the DOM is the DOM. The source doesn't execute the DOM, so it has no idea of it. You cannot just check the source code. So in source-based cross-site scripting, though, we do know a get and a post reflected cross-site scripting, depending if the parameter is stored in the database or not. Here it is depending on where the value comes from. So the value could be stored in the database and then be fed into a DOM sink, or it could just be reflected. When we talk about DOM sinks, we're going to talk about the locations where user-controlled data will enter that DOM. So your data is going to be fed into the DOM through a document sink. For example, element.innerHTML. We can, of course, in this case, the script alert script here is just not going to work. That is because we have several other tag vectors here that we need to take into account. This is a DOM insertion, so not just a reflection of that value. And when we speak of DOM insertion, that is, for example, why I always test with that broken image. Some examples of that are inner HTML. When you insert that broken image, you can see into an inner HTML that might pop, but a script alert /script here isn't going to pop. Outer HTML as well, insert adjacent HTML, document tetroid, and document.writeln. And these are just the JavaScript DOM sinks. jQuery laid on top of JavaScript has more. So we have different DOM sources and DOM sinks. We have location sinks, we have document sinks, we have execution sinks, eval, set timeout, set interval, and function, and we have the sources. Here is where your JavaScript property is going to accept data that is potentially attacker controlled. An example of a source is the location.search property, because it reads input from the query string, which is often in a one of those, you see a URL sometimes that has a hashtag in it. That is often data read from the DOM. Ultimately, any property that can be controlled by the attacker is a potential source, and this is going to include the referring URL, the user's cookies, and web messages. Some common sources include the URL, the URI, the URL unencoded, the base URI, the location. You can see here cookies and referrers, the windows.name, the history.push state, the replace state, and the local storage and session storage. If you want to test for DOM cross-site scripting, it's better to let vulnerability scanners do this, because this is one of the easiest cross-site scriptings that you can find with a vulnerability scanner. Now, of course, the best thing is to let it look for a DOM sync, let it try and crack it, and if it can't, you crack it yourself or try to crack it at least. The thing is, these are really easy to find. The sources are where your data comes from, we fit into a sync, and then you have potentially cross-site scripting if you're able to control it, but you need to find those syncs, and that can be really easy done with static code review. So you enter random data, you see in every single source, location.search, for example, and all of these sources, the URL, the cookies, the location, everything, you're going to enter a random value and you will see if it is reflected in any sync. If it is, then you're going to look, then we're going to look everywhere that our variable x is being used and check if it's being passed into a sync. And we'll need to again apply our regular HTML XSS routine to see if we can have a cross-site scripting attack here. The browsers will behave differently with regards to URL encoding, so just take that into account. If your data does get URL encoded before being processed, just know that an XSS attack is very unlikely to work. It's just, I don't want to go too deep into details here because it can get quite technical, but if your data is URL encoded, then you shouldn't worry about it too much. The same can be set for JavaScript execution syncs. We're going to enter a random value, find out where that data is being read from a source. Again, we can use the debugger to do that. That's a very useful tool. Track that variable, and if the source gets assigned to multiple variables or other variables along the way, you're also going to have to track those. Then when you found your sync, a regular XSS strategy can come into play again. So as you can see, this is quite technical and not always easy to find. That's why I'm not going to go too deep into it here, but just know that this is often handled by automated vulnerability scanner. Alright, so what we have here is an XSS cheat sheet that I worked a while ago, where we make the distinction between the XSS active hunting and the passive hunting. With the active hunting, we're going to try to, first of all, distinguish the types of cross-site scripting, such as reflected cross-site scripting, stored cross-site scripting, DOM cross-site scripting, and for each of these, we're going to see if we get a value reflection from get our post parameters stored in a database somewhere or put into a DOM sync. Then we're going to, as the test objective, identify where a value is reflected into the response, plus assess the input they accept and see if we can pass any filters for reflected, of course. We place that into the database for stored and into a DOM sync again for DOM. As step 1, we will detect the input factors by testing all of the parameters. That is basic knowledge for get and post, but also, of course, for DOM, basic static code review is going to work the best. As for step 2, we will analyze the results depending on the context, and we will find the DOM syncs by entering random values and looking at the developer console. This is important for DOM cross-site scripting. You need to use the developer console because they're talking about the DOM, the document object model, and you cannot test this by viewing the source only. And for step 3, we check the impact of the attack vector, of course. When it comes to passive XSS hunting, I've already said this before, but we have this string where we have a double quote, single quote, and then a other ampersand, a other quote sign, greater than sign, and then some kind of skewed text or underlined text in this case with a broken image. This is going to test for several different types of XSS. This is what's known as a polyglot, but I've tried to make it as simple as possible, so detection is much less likely here. Enter this attack vector everywhere, and you'll try to do basic attacks for different types of cross-site scripting. When it comes to filter evasion techniques, we can do some basic modifications. We have our attribute and our tags that we can play with, and our event handlers as well. We can put up some delimiters that we can play with, or we can use the eval as we've seen before, or we can use filtered words within filtered words. Of course, this is something that you need to apply at your own pace. You need to look at what's applicable and what's not. This is not something where there's one solution for everything. So you'll have to basically go through this, see which one is applicable in your scenario, which ones are filtered and which not, and hopefully you can report back to me with a bug. So now that we come into the filter evasion chapter, I would like to present to you this handy dandy little flowchart, which says start. We start, of course, at the beginning. We're going to try to find parameters, get, post, cookies, headers, API parameters, etc. As long as it's a parameter where we're going to try to identify the injection point, and into the HTML context we can go into the JavaScript context, into the tag attribute, into an HTML comment, into a templating engine. There's different contexts that we can land into, so we need to determine that. Then we need to check for any filters active, whether they're whitelist or blacklist based, and what exactly is filtered or not. And we have several different filter bypasses as well, of course. Something like HTML entities could be applied. So a payload could be less than sign replaced by ampersand LT, for example. URL encoding, for example, a %25, that would be the less than. A hex or Unicode encoding, which will be a less than, a backslash x3c. A mix of upper and lowercase, such as a script, for example, which we have sort of mixed the lowercase and uppercase letters around in. The inline comments as well. Different event handlers, so error, on load, on mouse over, etc. There's this handy dandy little guide, this cross-site scripting cheat sheet by Portswigger that you might be able to use. And we could do a JS eval as well, that is also sometimes used to bypass filters. Just know that in JavaScript itself there is no way to play with the capitalization of the words, because JavaScript is case sensitive. Now, if you're like me, you might find that JavaScript files hold a very much useful secret for you. It's only up to you to explore, to analyze the JavaScript, but how do you do that? Well, first of all, what is a JavaScript file? I hope you know by now, but it's a client-side object-oriented scripting language, making static websites dynamic, can changing a website without really loading it. Basically, something that gets executed in the client browser, not on the server. What can we find in JavaScript files? Very useful things such as new endpoints. Sometimes developers will create JavaScript functions for endpoints that haven't been mapped within the application yet. Hidden parameters, same thing, but also API keys. And something that a lot of people seem to forget is business logic. Sometimes you can find things like client-side calculations there. Also HTML, JavaScript, things for DOM cross-site scripting, of course. Secrets and passwords, sometimes even useful comments, who knows, and potentially dangerous areas in the code, such as eval, dangerously set inner HTML, etc., which the name says itself, I know, but you'd be surprised at how dumb a developer sometimes is if he wants to rush through things on a Friday evening. As for the attack strategy, we can do this really cool thing in Burp Suite where we can filter, and we can, for example, show only the JavaScript files. That will help us with exploring massively. We can also right-click on our target in the sitemap, and we can click Engagement Tools in the Burp Suite Pro version, and you can click Find Scripts. You can also use Wayback Machine, installing Wayback URLs. You can do that, and you can grab 4JS files with, for example, the command on screen. There are certain defense mechanisms in JavaScript files as well, of course, such as JavaScript minification, which is going to decompress using uglified.js. We can try that, but it won't always work. JS obfuscation. This is just something you'll have to figure out. And sometimes also JavaScript chunking, where they're going to split one big JavaScript file up into several smaller chunks. These are not per se to defend against cross-site scripting. I'm just saying they make it a lot harder for us to analyze this shit, and I'm not happy with that. Hello, you amazing hackers. Great having you back again. Today is going to be a bit of a special episode because we've reached 1,000 subscribers, which I'm very grateful for. I would have never thought there would be this much interest in the videos I make, so thank you guys for watching, and I hope you enjoyed this one. Today we're going to be telling you a bit about the importance of JavaScript files. I've touched on it a few times in the past, but I've never really gone into detail about why JavaScript files matter so much. So let's go to our choose shop again. We'll go to our home page, and here we can see a few JavaScript files. Now the first thing I always do when I enter a website is I just go and check out the main JavaScript file, if I can find it, of course. So that's what we have open here. We just go to the JavaScript declaration and we open the link. And then I just copy this over and I paste it into my Visual Studio Code, and I just pretty print it. I prettify the JavaScript. So that way it's a little bit easier to read. Now there are no shortcuts to success. You're going to have to read this full JavaScript file. I know it's like 8,000 lines long, almost 9,000, but you can guess a few things. But most useful will be when you just read the whole thing. If you don't understand something right away, that's okay, just note it down. But static code analysis is a really important part of bug bounty hunting. A lot of people have asked me how you find hidden endpoints and that kind of stuff. This is usually it. This is a really important source of information, your JavaScript file. And a lot of people will try to obfuscate it, so it's really useful if you know how to deobfuscate this kind of stuff. There are some tools for deobfuscation, but in my opinion, they don't really work that well. It's best to do it manually. So I'm going to be showing you a few of the things you can get from this specific file. So I've analyzed this before. One of the things I found was this administration path. I was trying to go to the admin page on my True Shop, so I went to the home page and I tried the usual things I would do when I brute force /admin. Didn't return anything, so it didn't work. Of course I tried administration, but they might have just as well called this blah blah blah, and you would have still gone to the administration panel. So when I go, of course I need to log in because I get a 403, so I just log in, and to go to the administration login I just do SQL injection. I also have a video about that which I will link about. So now when I open the administration page, as you can see, I'll see what happened on my Jew shop. So next thing I wanted to tell you guys is the file upload is also described in this specific, there we go. So here you can see that there's a file upload functionality described in this specific JavaScript file. Now what this is telling us is that allowed MIME types, it's filtering on the MIME types, the file upload functionality. So only these MIME types are allowed, which will tell us that we just need to change the MIME type if we want to do any file upload exploits. And the max file size, of course, is also pretty important because it will tell you what you can and can't upload. So this will tell you something about the filters that are in place. Sometimes you can also find information about cross-site scripting filters. There's a lot of information in here. Once again, you'll have to read the whole document. Now, next I want to show you guys is I'm going to just look for campaigns to see if they have any running campaigns. And as you can see, I can find some information about coupon codes in here, which will also be really interesting, of course. Maybe I can find a specific coupon code. Maybe I can find how it's validated. I'll leave that up to you guys. But there are certain things that you can get from this information. There's also some hidden information. For example, if we go to the token sale, app token sale, we can find out that there's a token sale going on soon. We can find out some information about that. I'll also leave over to you guys about what that kind of information is. And the last thing I wanted to show you guys is when I go, for example, to support, I can see that there has been some information. When I translate this information, I already did that for you guys. I get this. Our support team, our common secret is xing, and it's something I can't pronounce with the empty master password. So this indicates probably that they have some kind of key pass file or something else that's not really encrypted with another password, just the key file. So that's pretty much what I wanted to show you guys. This is why I keep telling you to read the JavaScript files. I know it's boring to go through pages and pages of JavaScript lines, but it's really a gold mine of information. And I hope you guys will see that when you try it as well. I hope you enjoyed this video. If you did, please leave a like. It would really help me with the YouTube algorithm, and share this video with your friends. Of course, if they're interested in hacking, don't bother them with useless stuff. And I hope you have a nice day. See you in the next video. Bye. Hey, what's up, you amazing hackers? Hope you're all doing well today. Welcome back to the channel. You asked for it, Uncle Red delivers. Yes, here we are again with some JavaScript for bug bounty hunters and ethical hackers. I'm going to focus on some specific things, specific exploits. I've made a little bit of an application, but it's not real, of course. It's just taken from what's supposed to be like a little bit of an application. So bear with me here. At the very top on line 4, you can already see var secret API token. So API keys are important, but also of course usernames, passwords if you find them, any kind of token. Make sure that that token is supposed to be private though. That's really important. Also, you can check on line 7, var debug mode is false. Now what is debug mode? Debug mode is, if you can see later on, it's going to log a whole bunch of stuff that it should not be logging. Then we go on to line 9 to 12, where we're just going to define a data array. Here we have a user ID that's empty and a token that is empty. Moving on to line 14, we are defining a function. In that function, we are trying to log in, passing the parameters username and password. We can see on line 16, however, that we're going to make a request to post login, continuation on line 17, and then we're going to set the headers on line 18, and on line 19, we're going to do a request where that username is simply sent in plain text. You can also see that data.userid equal, what am I saying? My apologies, of course. The XHR request itself is being made. And that XHR request is basically a request to the backend that contains that username and that password. Should never be sent in plain text, of course. Next up, we're going to go a little bit further onto line 20. We say if that request succeeds, just fill up that data object. Nothing really important here. And then on line 28, you can see that that XHR request fills in its body completely unprotected, simply sends it in clear text. Next up, we have the set debug mode. In here, we come back to what we've seen before. Debug mode equals status, and status is what we pass along as a parameter of the function. On line 37, we pass an if, and you may have seen ifs like this, or you may have seen them like on line 42. What's stated on line 37 says if the debug mode is active, it logs some information. There is no else there. You can write it like this, or you can write it like in the function debug log on line 40. If debug mode is active, it does a console.log of the message. That message needs to be passed by us. Next up, we have a function which really shouldn't exist, getSecretAPI token, even if that API token would have been a backend API token, not hard-coded in here. If this function would return setAPI key, that function is a vulnerability in and of itself. So we're going from line 47 to 50 here. I included some little comments. Just imagine that other application logic is defined in here. Maybe you can find some hidden parameters, some hidden endpoints, maybe some hidden functions. Those can be important. And we also expose some methods to the Windows object for internal script. As you can see, window.login equals login, the debug mode, and the secret API token. I hope that helped a little bit in maybe analyzing JavaScript some more. If you want to see more of this, let me know, because I love making these types of videos. It's really simple. You really just have to take a lot of time for JavaScript and investigate it properly. And if you see one of these functions, try to execute it in the console. Why not, right? Alright, thank you so much, amazing hackers. My name is thexssrat, and I'll see you in the next one. Hey, what's up, you amazing hackers? I hope you're all doing well today. Welcome back to the channel. And I'm sorry, but you will have to join me outside today because it's hot as balls. I am sweating my ass off, but I wanted to teach you a little bit of JavaScript anyway. So, on your screen right now, you should be seeing a little bit of JavaScript code which has some vulnerabilities. We'll go over them. But first of all, we need to go over things like express, which is going to be imported. This is an import this require. And then we say the variable app equals express. So we open a new instance of express. Then we're going to say for the body parser, we're going to import a body parser plugin. And we will use that. We say app dot use, so we call a method on app called body, and then in the parameters we enter the body parser dot json. Next up, we have dummy databases. Now these dummy databases right here, you can already see that the password isn't even encrypted, and we also have user secrets. Again, nothing here is encrypted, so that's a problem, but it's also directly in the JavaScript files. You will never really find this, but if you do, you know that it's probably a problem. When we talk about hidden API keys, I've talked about these before. These are really important to realize. Do I talk to a public API here, or am I talking to a private API? This really matters on that point. When we talk about the login route here, we can see that that API key is required, but once again, that API key is just in plain sight, so that's not a big problem. If we then say that the API key is invalid, so we check if API key is not the same as the hidden API key. API key is what we got from those headers. We can see that username and password are gotten from the body. And then we're going to enter a for loop. Now, a for loop, in case you don't know, it's going to keep on looping until the condition here is met. It starts with an initial condition, variable I equals 0, and yes, you can define your variables in here already. That's no problem. You don't have to define them outside. I is smaller than users.length, so it's going to go through all of the users, and while I is smaller than that, it's going to increase by 1 and continue. Now what you need to know is that that increase happens after, so this if is going to get executed, and then the increase to I happens. Then I becomes 1, and 1 is no longer smaller than the users.length, which is also 1, which is going to go out of this loop. Now while in this loop, it's going to check if the username and password are the same of that specific user on I. Does the user on I'm starting to talk in Dutch here to you guys. The user on I is basically the one that we are currently looping through, and we want their username and their password. So a variable, a property, not a method at all in this case. Next, we're going to say here res.send, so response.send, login successful, your secret is, and then the secret just gets exposed like that. That is, of course, a problem, but it's not something you can really use in bug bounties. In pen testing, of course, you really need to lay that out. On the hidden route right here, we have a route that's not available through normal use of the application. And here it's really important to always look for those hidden routes, for those hidden parameters. Always look for things that you normally aren't supposed to be able to see, hidden API keys, etc. Now here we have a search query, but we can already see. So first of all, we enter this property, the query itself, into a variable, and then we build up the page itself, and then we see here an HTML with a body and a results page, which we're going to insert our query into. That is a big problem, of course. That can lead to direct XSS, and this isn't a direct DOM sync. I'm sorry, I should have noted this differently, but you can also sometimes find DOM syncs. To know what they are, there are different ones in JavaScript, in jQuery. Look them up. Go look at my XSS videos. They're also pretty interesting, if I say so myself. And then we have these servers set up. Nothing really vulnerable in here, since the server needs to, well, this sets up a server at your local IP address, of course, so it's information about the backend, information disclosure, which should never happen, of course. But in essence, this isn't vulnerable in and of itself. This can help you with your further explorations, though. I hope you enjoyed, my friends. If you want to... Hey, what's up, you amazing hackers? I hope you're all doing well today. Welcome back to the channel. I've been asked a few times, should I learn JavaScript for bug bounties? And my answer to that is very simple. Of course you should. It'll only make you more proficient. I don't see why you should not. Now, I've also been asked the question, can you explain me a bit of JavaScript then? So, I've made the script, I've put it together real quickly to show you a few of the key factors of JavaScript and show you how you can maybe read JavaScript a bit more effectively, but also understand what it is, because JavaScript is a scripting language and it's a client-side scripting language, meaning this file gets downloaded and executed on your computer. So if I have a website and I'm building that and I want some interactivity on that website, but that interactivity doesn't require your server communication, then I might use JavaScript for this. Now, a first example is variables. You can see at line number 3, we define a variable with var name equals John. This is a string, but you can also indicate a variable through line number 4, let age equals 20. You can also define a constant. This is a constant, it's a variable that's never going to change basically throughout the execution of the script. We have on line number 9, we are going to start a function. A function is just a block of code. And we have a variable that we take in as a parameter called name. On line 10, we're going to console.log. If you've ever played with the developer tools, you have a handy dandy little JavaScript console there, and that is where these things are logged. Hello, and then you concatenate the hello with that name variable. Next, we need to call it on line 14, of course, otherwise this would never get executed. Now we have that name variable in there that we put through, but that name comes from line number 3, of course. Next up, on line number 18, we have a different type of variable. This is an object. And this is basically containers for named values. Named values, value key pairs is also called sometimes. Either, in this case, for example, a string, name John, a integer, age 25, or a boolean, is student true. Next up, we're going to again access one of those properties and log it into the console on line 25. What we're doing here is we're accessing that student object and the property name from it. Next up, at line 30, or line 29 I should say, we have arrays. These are again a special type of variable used for storing multiple values in a single variable. So if you have a collection, that can go into an array, for example. There are other data types, sorry about that, other data types, but I don't want to bore you with those yet at the moment. Maybe later, if you're interested. Just for now, it's going to be a bit more simplistic. And on line 30, we are going to access an item from that array at index 0, which is gonna be apple. Index 1 would be banana. That's what these are called, indexes, the number where that's at. Next up, at line number 35, we have what is known as a loop. This is a logical structure. This is going to keep running until it reaches that last point. So we have let I equals 0. Remember, let to define a variable. And then we say while that item array equals the full the array dot length is what am I saying? So while the I is less than the array dot length, we are going to go through that and we're going to go to the action which is behind that last semicolon, which is I plus plus, aka we're incrementing the value of that variable I with 1. On line number 36, we're going to output that into the console again, and we're going to loop through, and we're actually going to log every single value of that array that we have defined before. Now, another type of logical statement is an if statement on line number 41, where we say if the age is greater than or equals 18, then we're going to log in the console you're an adult. Otherwise, we will log you are a minor. And finally, on line 49, you will see a JavaScript event handler. So what this does is it says document, that is your HTML page, dot get element by ID. So you have on your HTML page an element with the ID my button. When somebody clicks on that, execute the function to just pop an alert, hello world. I hope that makes a little bit of sense. That was a bit of a basic explanation of JavaScript. If you want to know more, let me know in the comments below. Thank you very much for watching, and I'll see you in the next one. Bye, amazing hackers. Alright, let's talk about CSP, or Content Security Policy. Content Security Policy, what is it? It is true that it can be used to prevent XSS attacks. It's not the only purpose, there are other purposes. Basically, it is made up of directives. As you can see here, it can either be a meta tag or a header. And what you need to know is that this is browser-side protection. The server does set this protection, but the browser has to enforce it. So if you set this protection and your browser just doesn't support it, no bueno, no bueno. It's not good for you. There are different directives. So we can see there are fetch directives, document directives, navigation, reporting, and other directives. Let's talk about the fetch directives first. Fetch directives are control direction from which certain resources may be loaded. So for example, image source, as you can see, these are types: default source, script source, media source, and style source. The default source is the one where if none of these are applicable, the default source will apply. So for example, if you don't have an image source, default source will apply to all images, though images, scripts, media, style sheets. This can help prevent cross-site scripting because, for example, if I can only load images from the own thing, I cannot load external images, so I cannot send cookies off, for example. If I cannot load scripts from other domains, that might be preventing cross-site scripting to a degree. So there are different directives that can be set. As for the document directives, we have the base URI and sandbox, which enables a sandbox. This is always useful, of course, if you want to prevent things like cross-site scripting. Navigation directives, the form action and the form frame ancestors. The reporting directives being the report URI and the report to, and other directives being something like require SRI for, trusted types, and upgrade and secure requests. This is just for SSL requests. For if it's normally over HTTP, this will go over HTTPS. These are the values which we can use: none, self, and strict type, or sample report. Usually it's non-self, or we have unsafe keywords as well, such as unsafe inline or unsafe eval. These are keywords. We can put other direct websites in there. Keywords are just to refer to other websites. We have host values as well. For example, example.com, start.example.com, or HTTPS, the :/ the asterisk.example.com, and then we can also add ports if we want to, subdirectories, files, and even the extensions. The schemes we can also set, for example, only load from HTTPS, HTTP, or data. We have the examples here for you. This is a header content security policy where the default source is to self and the image source is to load from everything. We also have the content security policy here with the default source from everything and the images only loading from the domain itself. So in this case, that would be the domain drive.google.com. We also have some exercises for you. So let's go into those. Oh, of course, those are not going to work. I think I'm also going to be able to log into Notion in my browser. Let's see, otherwise I'm just going to open them from Chrome. There we go. So we have some exercises here set for you. If you want, we can go through them. It's very simple. I want to create a CSP header with the following properties. By default, I wanted to only accept any resource from the domain itself. I want the scripts to be allowed from google.com and images as well. We can set the CSP header to script source google.com as was asked, image source google.com, and the default source self. In question 2, we see that the default source should be from anywhere, which we see in a meta header, in a meta tag in this case, not a header. Default source equals self, that is true. Image source is going to come from HTTPS domains, any domain as long as it's HTTPS. And we have the child source none, and the style sheet source, or the style source in this case, from google.com. So that should be just google.com, of course. We need to remove google.com here because there's twice google.com. There we go. Question 3, the default source should be anywhere again. The style sheets come from google.com or yahoo.com. We can see that we can add multiple values as well if we want to. I need scripts to be evaluated unsafe inline. So unsafe eval or unsafe inline. Here we have a CSP. I cannot see this, so I cannot see. CSP is a server-side protocol, which usually does not involve the client. That is not correct, as we know, because the server sets it, but the client has to process it. CSV is enforced by the browser, and while it is not made to protect against cross-site scripting attacks, it can help them or mitigate their impact. CSP is an acronym for Content Security Policy. There we go. I know my shit. I don't need my answer sheets. You guys see that? Alright, my friends, that's it for CSP. Thank you very much. Appreciate it. There are some labs as well on labs@expert.com as per usual. Thank you so much. Appreciate it. And I'll see you in the next video. Alright, my friends, let me scroll up here as we talk about the Ultimate XSS Advanced Guide. Now, this part I'm trying to cover some more advanced topics, and we'll see where we get through, because we have some labs on some of these, but not all of them. I did want to touch upon them though, because you might be wondering where to go from since we are at this point now. Well, first of all, we're going to go over AngularJS, what their sandbox is. We'll talk about CSP, content security policy, dangling markup injections, chaining cross-site scripting, and XSSI. So let's talk about the AngularJS front-end first. It's just a front-end templating engine. Templating engine means that I can put shit in there, like for example, curly bracket, date, curly bracket closed, and that will give me, like, that's basically the date. Now, as for the let's talk a little bit about Visual Basic cross-site scripting. Yes, because ASPX is a scripting language. Now, what is it? The attack strategies, the defenses, and some further resources for you. This is very, very similar to JavaScript cross-site scripting. It is unsanitized input leading to cross-site scripting. But let's look at an example. You don't have to take my word for it. So here you can see a very basic web page. Here's the code behind it. For each feedback as customer feedback.feedback in view model, enter that message. So it's basically just an ASP page that's going to display every single message. Now, if we enter our script alert /script in here, our usual attack vector, if we close that with the double quote, of course, then we are going to get a pop-up just like anything. So we are inserting our JavaScript through a different scripting language, through the ASPX. It's very similar to other cross-site scriptings stored, it's other JavaScript cross-site scripting, I mean, of course. We're going to insert some attack vector, we're going to see if that renders, and we're going to investigate further. We can HTML encode the view if we want to, or the controller, because if you didn't know, this is a model view controller framework. And in this case, we have a lot of challenges. Again, we can sometimes filter certain things, we can bypass that. We can, for example, use %3c for a less than sign, or 3e instead of a greater than sign. We can use %gt. We can HTML encode these. This is more dangerous in areas where a user can have higher privileges and the attack is automatically executed by the browser. Again, it's very similar to other types of cross-site scripting, so I'm not going to go over how to test for this again. We have seen that in other presentations. It's exactly the same. The only thing that you need to know that's different here, there's absolutely no other difference, is going to be that your insertion point is going to be through an ASPX website. That's it. Alright, my friends, here I am on the red side. I'm going to show you something, because here I have a user. It's going to be the username test. This is going to be awesome, you'll see. So here I have, for example, an order. Let's see if we can make an order, because that would be very useful. One, and we're going to make an image with an alert. Just a very simple image. We're going to see that in the orders, does it pop or not? Unfortunately, it does not pop. That's no problem, because we can try that on other places as well, or we can try other things here. We have to change that, of course. But here, for example, we can try the same for an invoice. We can create a new invoice. Here we go. Let's give that a shot with a proper date, of course, and a state, and the total amount for the invoice. Let's submit this 10, and let's see what we get out of this. Alright, let's go to the invoices. Sorry if you hear a bit of scratching. It's just that we have like 6 threads here. Alright, we can see quite a few of the pop-ups appear right now. Now what I'm going to do is I'm going to delete those items, so at least quite a few are then gone, because this is not what I want to see, of course. I want to steal their cookies. Now this is going to be a post cross-site script if I want to do this, not self cross-site script. I'm sorry it's laughing, but there are like 3 rats on me and it's a fucking joke. But I love these guys, so let's go on. So here we have some other things as well. We can, for example, do some other types of cross-site scripting. We have the same image. The problem here. There we go. What can we do with this? Now let's go and find XSS cookie stealers. I like to use this page for XSS cookie stealers and specifically, and it has a Python script with it, but I have these. I just like this. So what I'm going to do is I'm going to set up an out-of-band server on webhook.site, for example, and here I can see that I have a unique hook URL. If I copy what I have here, let's do that for a moment. Where is my, let's copy the whole thing, so we just have to replace a few things. Let's go back to red side. Let's change this URL though with the URL that we just had. There we go. Let's change that and copy this, because that'd be our unique URL. And let's paste it in. So we can see that the page is continually refreshing now, and we can see that we also get in some requests in which we can see that we get specific cookies. Let's just see if we can copy what we need out of here, because it might be a little bit confusing. But if we zoom in a little bit on this, that's gonna be no problem, of course. We can see that we have some cookies here. Now if I copy these cookies and I put these values in where I need them, I need the right cookie though. So we have a GA cookie, we have another type of GA cookie, we have again some kind of cookie right here, ID equals, we have an RT cookie. What I'm looking for basically is gonna be a session ID. We can see that right here at the end. So let's copy this value, or wait, let's first of all copy the value right here so we can go to the red side. We can open that in a new tab and we can see that we are not logged in, but we have to edit this cookie thing right here, and we do have this session ID. Remember, we had that in our other browser right here. Let's put these together a little bit so we can click them. So we have our browser right here with our cookie. Let's mark that once again, and let's go back to the other page, and here we want to change our cookie to what we had before, but let's just get rid of this junk. So it's gonna be with this semicolon separation. There we go, and we need to get rid of this junk in front of it as well. Alright, now let's set the cookie to this and refresh the page. You can see that I actually took over an account. Let's go back to my user settings. There we go. I smuggled out data to take over an account. How freaking cool is that? Awesome, my friends. I hope you learned. Try this as well. Try this for yourself step by step. And I'll see you in the next one. Bye, amazing hackers. Alright, amazing hackers. Welcome to the new section of our exploration, this time into mutation cross-site scripting, abbreviated as mXSS. Unlike other forms of cross-site scripting, mXSS exploits the inner workings of a browser's HTML parser to execute malicious scripts. The real-world impact of mXSS can be significant, leading to data breaches and other security-related issues. Alright, sorry about that. So there we go. At its core, mXSS involves 3 steps: the malicious user input, the browser's mutation of that input, and of course the eventual execution of an unexpected script. When a browser parses HTML, it may change or mutate that code. Mutation XSS exploits this behavior by injecting malicious code. Once mutated, it becomes a security threat. The input phase is where the attacker provides a malicious script. During the mutation phase, the browser's HTML parser changes the input in some way. And finally, in the execution phase, the mutation script is executed, often as the result of being assigned to an element's inner HTML property. Different browsers have different parsing behavior, which can lead to discrepancies in how HTML is rendered, and it can be exploited for a malicious mXSS attack. So here, let's look at a code snippet to better understand mXSS. Initially, a malicious payload is crafted with a single script to execute the alert 1 on an error event. So we can see that right here. We can see just a normal image source X on error equals alert. The browser's parser may change the single quotes to double quotes. We have seen that before in our labs as well, if you've been paying a bit of attention. And the browser's HTML parser changes it to the mutated payload on screen. When this mutated payload is assigned to an element's inner HTML, the malicious script is going to be executed. Preventing mXSS involves input validation, sanitization, and implementation of a robust content security policy, a CSP. Libraries like DOM Purify can help sanitize HTML to prevent mXSS, but as we'll see later on, they might also make trouble because of it. We'll see later on what I mean with that. On this slide, we can see the testing for mXSS can be done manually or using automated tools. It's crucial to test across different browsers due to their varied parsing behaviors. And what is happening here is you need to understand these parsing behaviors by reading the RST for HTML. Like, there are different parsing behaviors. If you enter a single quote, sometimes it will be corrected to a double quote. Sometimes it will not be corrected to a double quote. It all depends. There are different correcting behaviors here. Over the years, there have been some real-world examples of mXSS exploits as well, such as Bookworm, an HTML input sanitizer which is vulnerable to mutation XSS. The payload could be stored and displayed on the home page's website, path/feed or/discovery, making it widely affect all users on the main website. I'm sorry I'm laughing, but there's literally a rat crawling in my shirt right now. This guy is really a cuddly bear. So, as you can see, it is not always foolproof, let's just call it this way. mXSS is a unique and challenging form of XSS to mitigate due to the unpredictable nature of the browser's parsing. Protecting against mXSS is a crucial aspect of securing web applications. I guess stop scratching me, you dick.